You know, it's the stuff that powers our cars, makes our plastics, and has, well, pretty much shaped the entire modern world. But what is petroleum really? And where in the world does it come from? In this explainer, we're going to go on an incredible journey, a billion-year journey actually, all the way from microscopic critters in ancient oceans to the stuff you use every single day.
Okay, so here's how we're going to break it down. First, we'll figure out what this rock oil is and look at its surprisingly long history. Then, we'll dive into nature's super slow cooker recipe for making it. After that, we'll see how we humans got so good at hunting for it. We'll take a peek inside the massive industrial kitchens where it's refined. And finally, we'll tie it all back to the world around us.
All right, first things first. Before we go any further, let's really get to the bottom of what this mysterious black liquid actually is. And it turns out the biggest clue is right there in its name.
So get this, petroleum literally means rock oil. The name itself tells the story of what it is. It's an oily, organic liquid that we find trapped inside layers of rock deep within the earth. It's basically a super complex soup of hydrocarbons with a little bit of other stuff like nitrogen and sulfur thrown in.
And you won't believe this, but long before the first car engine was even a dream, people were already using petroleum. Ancient civilizations would just scoop up the thick black goo that seeped up to the surface and use it for some pretty ingenious things. I'm talking about waterproofing ships, building legendary weapons like Greek fire, and even using it in medicine and for embalming mummies.
So if people were just finding this stuff lying around for thousands of years, how did it even get there? Well, the answer is an incredibly slow, planet-sized cooking process that takes millions, even hundreds of millions of years.
Okay, so it all starts in the ancient oceans with tiny little organisms, mostly plankton. When these critters die, they sink down to the seafloor and form this thick, gooey layer of organic matter. Over millions of years, sand and silt pile on top, and all that weight and pressure squeezes it into a waxy material called kerogen. Then, as it gets buried deeper and deeper, the Earth's natural heat essentially cooks that kerogen, breaking it down into the crude oil and natural gas we know today.
Now here's the thing. For this whole recipe to work, the temperature has to be just right. You can't just throw it in the oven. It's got to be in a very specific geological sweet spot. And that perfect temperature range has a name. Geologists call it the oil window. If the rock is too cold, say below 50 degrees Celsius, that organic stuff just stays trapped as waxy kerogen. But if it gets too hot, over 150 degrees, it gets overcooked and breaks down into natural gas. To get that perfect crude oil, nature has to hit that narrow window just right. Okay, so we've established that this incredibly valuable rock oil is cooked and trapped thousands of feet underground. So how on earth did we go from just scooping it out of puddles to building a massive global industry to pull it out of the ground?
Well, the modern oil age really kicked off in 1859. That's when a guy named Edwin Drake drilled the very first commercial oil well in Pennsylvania. And from there, things just exploded. Just 4 years later, we had the first pipeline. By the early 1900s, huge discoveries in the Middle East started to shift the entire global balance of power. And by 1961, the big oil-producing countries had formed OPEC to coordinate everything. It's wild. In just 1 century, oil went from a local curiosity to the absolute foundation of the global economy.
And our methods for finding this stuff have changed just a little. Back then, you'd basically just walk around looking for oily puddles on the ground. Today, geologists use satellite data and fire powerful seismic waves. Think of it like an ultrasound for the entire planet, deep into the Earth. This lets them create these incredibly detailed 3D maps of what the rock layers look like miles underground, pinpointing exactly where oil might be trapped.
And just to give you a sense of the sheer scale of the engineering today, check out this number. Modern oil companies can now drill for oil in water that's over 3,000 meters deep. That's like stacking 8 Empire State Buildings on top of each other just to get to the starting line on the ocean floor. It's absolutely incredible. But hey, getting the oil out of the ground? That's only half the battle. The raw, crude oil that comes out is this thick, gooey, complex mess. And honestly, it's not very useful like that. To turn it into the products we actually use, it has to go to a refinery for some serious processing.
The best way to think about a refinery is as a massive, high-tech industrial kitchen. Crude oil is the one basic ingredient that goes in. But out of it, engineers can cook up hundreds of different, very specific products, from gasoline all the way to asphalt.
So the very first and most important step in this kitchen is called distillation. What they do is heat the crude oil up so hot that it turns into a vapor. Then they pump that vapor into a giant tower. As the vapor rises up the tower, it starts to cool down. The different components then turn back into liquid at different temperatures and are collected on trays at different levels. The lightest stuff with the lowest boiling points rises all the way to the top, while the heaviest stuff stays near the bottom. It's a brilliant way to sort that whole complex mixture. And this process lets them separate everything out with amazing precision. Right at the top of the tower, you get the really light stuff like propane and butane, which become LPG for cooking. A little further down, you get gasoline for our cars. Below that, kerosene, which is what they use to make jet fuel. Then comes diesel for trucks and buses. And all that thick, heavy goo left at the very bottom, that's what we use to make things like asphalt for our roads.
So we've seen how petroleum forms over millions of years, how we hunt it down, and how we cook it in a refinery. But what does this whole immense journey actually mean for us in our day-to-day lives?
Well, when we think of oil, our minds immediately go to energy, right? Fuel for cars, heating for homes. But honestly, that is only part of the story. Those different components that are separated out in the refinery, they are the fundamental building blocks for so much of our modern material world. Those refined hydrocarbons are called petrochemicals, and they get transformed into a truly mind-boggling array of products. I mean, just look around you. The plastic in your computer or phone, the synthetic fibers in your clothes, the detergents you're clean with, the paint on your walls. Yep, pretty much all of it started its life as crude oil pumped from deep underground.
And as you can imagine, powering and building our world this way requires a colossal global industry. And while lots of countries produce oil, the entire market is heavily influenced by just a few key players. The decisions made in places like Saudi Arabia and Russia can affect the price of gas for all of us, no matter where we live.
And the scale of what we're all relying on is, well, it's just staggering. The estimated proven reserve of crude oil worldwide is over 1 trillion barrels. That is an almost incomprehensible amount of energy and material, a finite resource that took nature hundreds of millions of years to create.
And that brings us to the final big question, doesn't it? For over a century and a half, our entire civilization has been built on this ancient, buried energy. This billion-year journey is what powered our world. So the question we have to ask is, what journey is going to power the next one?